Welcome to an algebra review tutorial video. This specific video we're going to be talking about polynomial operations, and some of the specific operations we're going to be working with are adding and subtracting polynomials, multiplying polynomials, and also factoring polynomials. So if these are these are skills that you're going to keep coming back to over the course of the year, so I would really recommend to just know where this video is. So if you get to a problem in your homework set and you know that you're going to need to use factoring and you just can't remember how to do it, come back, fast forward through the video and get to the section that you need so you can get help on it. This will be good reference throughout the rest of the school year. So first of all, let's take a look at adding and subtracting these polynomials. Now when you're adding, it's going to be a pretty straightforward process. Subtracting could be a little bit different, but the big thing to keep in mind is that we are just combining like terms. Okay, so whenever we're trying to find like terms, the first thing that we need to remember is the basic requirements. So in order for two terms to be like terms, they have to have the same variable, x, y, p, q, whatever it is. They also have to have the same power on the variable, so an exponent of either 2, 5, whatever it is. Now, once you identify what your like terms are, then all that you have to do is add the coefficients that are in front of the terms. Then you can just make sure that you bring whatever the variables and the exponents, just kind of bring those along for the ride and just stick those next to your coefficient that you're going to have at the beginning. Let's take a look at some examples of the sort of problems we're going to be seeing. So if we were given this problem, the x squared plus 5x minus 3x squared plus 9x minus 7, first let's try and find our like terms. What we notice is we have a couple of terms that have x's, but specifically we have two terms that have x squareds. So I identified those as like terms by circling them. Also, notice the 5x and the 9x. Both of those, again, have the same variable and the same exponent. So those are also like terms. And then that 7 is left by itself because it has no variables next to it. So it's going to be kind of its own like term. Now all that we have to do is add the coefficients in front of these. So for the x squared, first we'll recognize there's a 1 in front of there. If we add our 1 and negative 3, we get our negative 2x squared plus 14x minus 7. So very similar to the sort of things that you guys did in Algebra 1 when you were dealing with this. Now, when we take a look at another sort of problem, so here let's start to look at the ones where we're going to be using subtraction. Alright, and in general, whenever you see that you have a lot of stuff that is grouped together in parentheses, it's often time to just stop and just double check and be very careful. If you look here at this problem, we have our 3x squared minus 9x plus 17, and then we're subtracting our second parenthesis. Since we're subtracting our second parenthesis, we have to do something a little bit different. Notice though, if that was just adding the second parenthesis, all that you would do is you would just kind of drop all the parentheses and then combine like terms. But since we're subtracting, what we're going to have to do is distribute that minus sign through the whole second parenthesis. Now, I know it seems a little bit strange, but once we do that, then the rest of the problem is going to work out just like we did before. So if we distribute that minus through, we're going to end up with this as our expression. Now again, we can identify all of our like terms, and once we identify our like terms, we can move forward. I want you to take just a moment here, pause the video, see if you can simplify this, and then move on so you can double check your work. Alright, so there is adding and subtracting polynomials. Now let's take a look at multiplying polynomials. When we're doing this, all that we're going to want to really remember is the distributive property. Now this is going to be a really big distributive property, as in the case of the binomials that we're going to be working with, binomial meaning that there are two terms inside the parentheses, we're going to be distributing stuff through twice. So let's take a look at an example where we're going to see that. So notice we have the binomial 2x minus 7, bi again, two pieces in the parenthesis, and then 3x plus 4 is what we're multiplying it by. Let's just distribute that 2x minus 7 through the second parenthesis. So here when we do our distributing, we're just going to distribute each piece like normal. So the 2x through the whole second parenthesis, and then we're going to multiply the minus 7 through the whole second parenthesis. Now the only thing to be careful of here, make sure when you remember to multiply 2x times 3x that we get 6x squared. Okay, be careful with that piece. Once we do all of our multiplication, now the only piece that we have left is a little bit of combining like terms work. We see that we have our like terms there in the middle where we have an x in common to each, so our final solution would be listed there below. So really these aren't going to be anything that are too terribly difficult for you as long as you're comfortable with the distributive property, combining like terms, and also the basic integer rules of negative times negative being a positive and so on. So just attend to those things. So take a moment, pause the video, and try out these problems that you see here that are coming up on the screen. Alright, that was multiplying polynomials. Let's move on to our last one of factoring. And what we're going to focus on today is we're going to be factoring kind of the simplest case where the leading term, the number in front of the x squared, or the a term, is 1. Now, there is going to be a separate video that you'll see here of how you go through the process of factoring whenever the a is not equal to 1. So we'll be going through that in a little bit more detail later on. But right now, when a is equal to 1, there's really only one thing that you want to keep in mind. We want to find two numbers that multiply to give us c and that add up to the b. So here, once we do that, then all that we've got to do is write our two parentheses, and these are going to be the simpler parentheses where you have the x in the front of both parentheses. Then those two numbers that we just found in that one step are just going to kind of get filled into the two gaps. Let's take a look at an example, and I'm confident that you'll remember exactly what I'm referring to here. So here our c term is 6. So we want to find two numbers that multiply to 6. So first let's start off by listing all of the numbers that would multiply to 6. Now many of you guys of course are remembering that after you get good with this you don't have to list all of these. But here in this one we'll list them out. If we list all of them, those are the only four combinations of numbers that multiply out to 6. Now the other thing that we need is we want our two numbers to add up to the b term, which for us is 5. So if I go and I test each of those, the 1 plus 6 equals 7, 2 plus 3 equals 5, I find that there's only one combo of numbers that work, and that's the numbers 2 and 3 because they both multiply to 6 and add up to 5. So since I see that, then my final factored form would be a parenthesis with an x in the front. Then I would have a plus 2 for the positive 2. Then the second parenthesis would again have the x in the front and a plus 3 for the positive 3. So here are a couple more problems that I want you to try out. So pause the video once you get to these, factor these out, and then double check your work as you go through. Again, make sure guys, these are skills that you're going to be using all over the place through geometry. You use them a lot in Algebra 1, and they're going to come back again in Algebra 2, I promise you. The better you get at this, the faster problems will become. So feel free, please come back to this video, use this as a meaningful resource that you can come back to over the course of the year. Make sure, use every tool that you have to help you get ready to go whenever it comes to solving some of these bigger problems. Alright, bye.